why do we always discuss using a mesh when we're talking about a finite element analysis? And the best way to explain this is simply to compare to the beam analogy, which is to say that when we analyze a beam, as long as we know the displacements at the ends of that beam, the displacements at any of the intermediate points along the length of the beam can be calculated or described by known formula or by known principles, like the moment area method. Unfortunately, we don't have similar equations to be able to describe the deflections of intermediate points on plates. So what we end up having to do in a finite element analysis is describe the deflections that occur at the nodes or the joints or the points of connectivity between adjacent plates. And similarly, in a finite element analysis, we're only able to pick up stresses accurately at the centers of the individual elements. So if there was any reason to need deflections accurately at points other than at the corners, the extreme corners of a structure, and after all, there always is, we're always interested in knowing deflections of a slab at an elevator shaft interface or some other such thing, then there's a reason to need nodes at points other than at the extreme corners of the building. To look at this another way, if there's ever a situation where we need to accurately predict stresses at a location other than at the geometric center of, say, an entire floor plate of a building, and after all, there always is, we're commonly interested in stresses at inside corners, slab depressions, openings within the floor, point loads somewhere at the interior of a slab, and so on. These all point up reasons why we would want to create a mesh that would position the centers of elements relatively close to those points of interest. So for two reasons, one having to do with predicting deflections and one having to do with predicting stresses accurately, we have need for nodes at intermediate locations within a floor or within a structure, and also centers of elements at intermediate locations within a floor or a structure. So it's impossible to accurately predict the behavior of a structure using just a single plate. Our solution to that is to describe that floor plate with a mesh of nodes and be able to pick up these stresses and deflections at all of those intermediate locations and centers of plate elements.